welcome to Math Mini Lessons. My name is Sarah, and in this lesson we're going to add or subtract radicals. So while I'm modeling these two Regents problems, I want you to look to see how I calculate the factor pairs for the radicand. That means the number that is under the square root symbol, how I identify square factors as well as rewrite the expression, and how I identify when I can combine like terms and when I can't. Let's jump into the first teacher model, which is a Regents level question. The expression square root 27 plus square root 12 is equivalent to which of the following? Alright, so this is a radical problem because I have two numbers under a square root symbol that can't be added together. There's nothing alike about them, I can't combine them. So for a problem like this, what we're going to do is we're going to factor the radicands. And the radicands are just these numbers that are underneath the square root symbol. And what you're going to look for is you're going to look for a common factor, a GCF, a greatest common factor, plus a square number. So that's the factor pair you want. Once you have that, you can rewrite the expression and simplify it, because now we'll be able to combine like terms. So we're going to start with looking at 27. And what are the factor pairs for 27? I can do 1 times 27, and I can do 3 times 9. 9 is a square number. Let's see if 3 is a GCF. So for 12, I have 1 times 12. I can do 2 times 6, or I can do 3 times 4. And 4 is a square number, so that works, and I have my GCF. So that's really what I want. So my greatest common factor is 3, and each of those, the other factors, are square numbers, which means I can actually take them out of the radicand. So let's rewrite. Square root 27 is going to be 9 times 3 plus square root 12, I can rewrite as 4 times 3. I know what the square root of 9 is. That's going to be 3. So I can rewrite this as 3 square root 3. And the square root of 4 is 2. So I can rewrite this as 2 square root 3. Now I can combine these together to get 5 square root 3. Why? Because it's almost like having, think of it like if this was 3x plus 2x, we would be able to add them together because now we have 5 x's. This is very much the same thing where I'm adding these whole numbers together and this stays the same. It's just my square root 3. And this is how I would simplify a radical problem. The answer is A. So we're going to use these same steps, and I'm going to add one small layer of complexity in the next problem. But we're going to do the same thing. Factor the radicands. We're going to look for a GCF with a square number factor pair. And then we're going to rewrite the expression so we can combine like terms. All right, here's our second problem. It's also a Regents problem. Notice same radicands, but I've added now a number in front. So what is the sum of 2 square root 27 and 4 square root 12? So same thing, 2 square root 27 plus 4 square root 12. We already know that the greatest common factor is going to be 3 and that they have square numbers. So let's rewrite it. For 27, we knew the factor pair for 27 was going to be 9 times 3. So I'm going to have 9 times 3. And the factor pair for 12 was 4 times 3. So now we can rewrite these in the same way. But let's look at the one thing that's different. So I know that the square root of 9 is 3. So now I'm going to multiply that with my digit on the outside. So 2 times 3, square root 3. So now this will become 6 square root 3. All right, because now I found the square root of 9. It's going to be a 3 on the outside. I already have a 2 there, so now I'm going to multiply them together. That was my square root. And I'm going to do the same thing here with the second one. The square root of 4 is 2, so 4 times 2, and that leaves my square root 3. And now I'm going to simplify this to 8 square root 3. Now I can add these together because, again, they have like terms. So 14 square root 3 is the answer, or A. Alright, so you're going to go through the same process today in your work. We can add or subtract radicals when we're able to factor them and find a greatest common factor that is paired with a square number. If they have a GCF but the other pair isn't a square number, I can't simplify it in the same way that we did here. But you're going to see problems that have just a simple number under square root. But also don't be surprised now if you have a whole number on the outside. Now we know what to do, which is to just multiply that square root with whatever digit is on the outside. Once we have like terms or we have the same radicand, then we can add them together, and we're only adding those whole numbers together. Alright, that's it for today, Math Marbles. I hope you found this helpful. I like this lesson a lot, so let's get some practice in, and if you have any questions, leave them in the chat. I will see you in the next one. Be well.